All right, as we get started today, I want to finish up that SAT prep, and then in the next part of the video, we'll go over the ACT prep that you had for homework last night. But let's finish up those last 3 problems. Now, I skipped 24 yesterday, and so let's take a look at 24 and start there. And they just make this thing annoying as all get out. Go ahead and read what they give us here, Josh.
For line H, the table shows 3 values of x and their corresponding values of y. Line K is the result of translating line H down 5 units in the xy plane. What is the x-intercept of line K?
All right, so just out of curiosity, what answers did we put? C? What you have? I had C, because I didn't read it carefully enough. C is the x-intercept of line H. But they wanted the x-intercept of line K, which is 5 units down from line H. So that's why I put C, which was wrong. It is D. Let's take a look at this. First thing I did was I remember that for a linear equation, we want it in what form, guys? Which is? So ultimately, I want to know the slope first, right? That's always the goal. So what I did was I looked at the x values and I looked at the y values. Start with the first x and then look at the first y. From the first x to the next x is a change of 5. And then for the y, the first change down is a change of 30, right? So there's a change of 5 corresponding with a change of 30. Let's make sure that's consistent. It says it's a line, so it should be. Let's make sure that's consistent. The next one has a change of 3 and a change of 18. We realize an increase 5 and an increase 30 is the same thing as increase 3, increase 18, because for every 1 you go up in the x, you go up how much in the y class? 1 to 6, right? This is a ratio of 1 to 6, 1 to 6, 1 to 6. Now, that doesn't mean the slope is 1/6, because remember, slope is what over what? Rise over run. The rise is 6, the run is 1, the slope is 6. That's the first thing you had to figure out. You have to figure out what the slope is doing. The slope is clearly 6. Okay, then you'll remember from Algebra 1 and Algebra 2, both years, we said this. You can determine the y-intercept by plugging in values. So, I know the slope, I now want to know the y-intercept. So we plug in some random points. Well, the easiest numbers are 18 and 130. I mean, it's pretty dumb that those are the easiest numbers, but they are, okay? So if I plug in a 130 for y, 6 of course is my slope, and I plug in the 18 for x, it'll allow me to find my b value, my y-intercept. Well, on your calculator, 6 times 18. 108, move it over as a negative 108, what's the b value? 22. And this is where I got hung up, because this is all line H. Y equals 6x plus 22. That is the equation of H. But they don't want to know about line H. They want to know about line K. And what does it tell me is true about line K? Line K is the result of translating it down 5 units. Well, if you take this same equation and shift it down 5 units, what's your equation going to become? 6x plus 17, right? That's going to be down 5 units because the y-intercept is 5 units lower. This is the equation of line K. But what do they want to know? They don't want to know the y-intercept of K. They want to know the x-intercept of K. Well, remember for the intercepts, we said the x-intercept always has a y value of 0, correct? It's something 0. That's an x-intercept. Well, that means you have to plug in a 0 right here for the y. We ditch the 17 as a, and divide away the, apparently, negative 17/6, 0 is the x-intercept of line K, and that's answer D. Now, if you did that same thing here, that's what I did. I was like, oh, I want the x-intercept, right? Plug in a 0, move the 22 over as a negative, divide away the 6, negative 11/3. Boom, I'm done. Oh, that was line H. Dangnabbit, line K, down 5 units. Okay, so it does pay to read the question carefully. Does that make sense now, though? We remember slope-intercept form, how to find the slope, how to find the equation y equals mx plus b, getting that b value. All these things from Algebra 1 and Algebra 2 that, You know, it's been since third quarter last year we had to use this. Questions?
No.
And not just use it, but then apply it outside the realm of, you know, what we always did in class. Yeah. So, kind of an annoying one. That's why I didn't want to do that one yesterday at the end of the hour, because I knew that was going to take us way past the bell. Number 25 ended up taking us way past the bell anyway. But there we go. There's number 24. Now let's get back to number 26. Read number 26 for us, if you would, Adam.
For each real number R, which is the following points lies on the graph of each equation in the xy plane for the given system.
All right, so they give us a system of equations here, and you see it. 2x plus 3y equals 7. And by the way, look at the bottom equation. In Algebra 1 and Algebra 2, what would I tell you to do in the bottom equation? Pull out a 5. And what would it give us, class?
2x plus 3y equals 7.
Do you realize it's the same thing? What we would have here, gentlemen, is an equation that looks something like that, and then another equation that looks something like that. You remember we called it an indeterminate solution? It was a dependent system. So in Algebra 2 last year, again, for those watching on YouTube, Scott, that would have been 2 years ago, students in California probably 2 years ago. But whenever we had this, we said we could substitute a parameter to help us represent the solution. We said we pick a random letter like T, they use R, and use R or T, in this case R, to represent either X or Y. It didn't really matter. So let's suppose we let R be X. Didn't matter which equation, it's the same anyway. What would we get if we solved for the other letter Y? Well, first class, to get Y by itself, we'd have to ditch the 2R as a negative 2R, and then divide both sides by 3. So 7 minus 2R thirds is one way to express it. Is anything that answer?
No.
No. They come close on letter C, but their 2R isn't negative, is it? And a letter D, they're close, but the 3R, the letter D is not even close, because they have it over 2 instead of over 3. So yeah, that's not even close. Okay, so then the other alternative is, instead of letting X be replaced with R, we could let Y be replaced with R. All right, now we solve for X. How do I get X by itself? Let's first ditch the
3.
negative 3R, then divide away the 2. Okay, so that means that R is the Y value, and X is 7 negative 3R over 2. Do any values match that? But it's sneaky. Another way to write this would be negative 3R over 2, positive 7 over 2. You see it? 7 over 2, negative 3R over 2. And that's letter B. And B is the correct answer. So it's really just using a parameter to represent the solution to an indeterminate solution for a dependent system of equations. Yes, sir?
So B is the y-intercept?
I'm sorry?
B is the y-intercept?
Not the y-intercept. B is literally every one of these points. Because whatever you plug in for R, that gives you the corresponding X value. So that was how we represented the solution to a dependent system, going back to Algebra 2 last year. Not allowed to forget anything. You knew it last year in Algebra 2, it's been a while.
I don't remember it now.
Yep, well, now, again, depending on how dedicated you are, you could go back to the Algebra 2 playlist, go back to around lesson 130-ish is around where that would be, or you'd be like, gee, I hope that question ain't on the SAT, and move on with life. Because that is a very nitpicky detail from Algebra 2. But again, what they're trying to do, to see who's the most college ready, to separate the excellent from the good from the mediocre, is they put questions on here that the excellent will remember, and the not excellent might miss, and that helps them separate who's ready for Yale, who's ready for Alabama, and who's ready for Chattahoochee Valley Community College. Again, it is what it is, right? But there you go. They expect you not to forget anything. Now, number 27. This is something I think we should remember a little bit. Read number 27 for us, Josh.
The perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is k squared at 3 centimeters, where k is a constant. What is the value of k?
Equilateral triangle, right? If they give us the perimeter, 624, I know how big each side is. How do I know that?
Okay, 5.
Divide by 3. So how big is every side, guys?
200.
208. But then they talk about an altitude or the height of the triangle, correct? Well, do you remember in equilateral triangle, what does the height or altitude do to the base?
Bias.
It bisects it. Now again, it's not drawn perfectly, but each side then must be how big?
104.
104. Now, keep in mind as well, if it's an equilateral triangle, how big is every angle? 60 degrees. Which means that this 60 up here has been bisected, remember, into a pair of
30.
which means this is a 30, 60, 90. 104 is like X or K. 208 is like 2K. And the altitude is going to be K times the square root of 3. What's the value of K, class?
104.
104.
Yeah.
This whole thing is 104 times the square root of 3, but what's the value of the K? 104. And that's the correct answer for number 27. Did we have that? You did not. Does it make sense now? We actually did problems very similar to this in geometry class a couple of years ago. Obviously, Scott last year. But did problems very similar to this in geometry. And it's just 30, 60, 90. But again, it requires, can you picture with the equilateral triangle 30, 60, 90? It would help if you drew a picture. And I'm noticing as I look at your paper, no picture drawn. Use the scratch paper. Draw pictures anytime you get a chance. Draw those pictures. Well, it says equilateral triangle. You know what that looks like, right? Didn't click. Well, again, drawing a picture might help it click. So that would be my strategy, right? For those watching on YouTube, draw pictures, help yourself to visualize these things. But there we go. There's module 1. I would say out of the 27 problems, there were at least 3 or 4 that I would say just really diabolically hard. There were another 3 or 4 that were challenging, but I think you ought to be able to get. And then the last almost 20 or so I thought really weren't too bad at all. So that's looking at module 1. And a little bit later on in the course sequence, somewhere around lesson 31, 32, I think you'll have the second half of this practice test, module 2, coming up. Remember, the SAT format now is you're taking it all digitally. Most of the answers are multiple choice. Some of the answers in each module are not multiple choice. That very last answer was not a multiple choice option. You work it out digitally, though you use your calculator still if you want. You still have scratch paper you can use. Once you've completed the first module, the second module, remember, is adaptive. If you've had some struggles on module 1, they'll give you easier questions with lower point potential. If you've done outstanding on module 1, they'll give you more challenging questions on module 2 with a little bit higher point earning potential for each one you get right. That second half adapts to you just a little bit to try to let you shine if you've been doing really well, or cut you a little slack if you've been having some struggles. That's the digital SAT. That's new as in 2024, 2025. All right, questions at all on this, gentlemen?
Will they give you like these references and stuff?
Yes, the references are given on both modules. Yep, and you'll see that when you get module 2 later on. They give you all of that information up front, so if you need it for reference. And you'll actually see in about, again, it's about 7 or 8 lessons away. When you get to module 2, you'll see that you'll actually need some of these formulas, because you don't remember these from junior high. You shouldn't have to. No, special right triangles, Pythagorean theorem, okay, that you should remember. But especially that solid geometry stuff, you don't remember that from junior high. So, and ACT does the same thing. ACT also gives you those formulas if you need them. All right, any other questions? All right.